The name of this lesson is Indirect Measurement. It says, I will be able to apply proportional relationships to real life situations to determine unknown measurements. So we've talked about 3 different ways that we can prove triangles are congruent, and similar. And we have angle-angle similarity, side-angle side, and side-side-side. If 2 angles of one triangle are congruent to 2 angles of another triangle, the triangles are similar. If in 2 triangles, if a pair of corresponding angles is congruent, and the sides including the angle are proportional, then the triangles are similar. And if all 3 pairs of corresponding sides of 2 triangles are proportional, then the 2 triangles are similar. So first we need to determine if we have similarity, and then if we do, then we can set up proportions or use scale factor to find missing measurements. So in example 1, we have 2 triangles. We have this triangle right here, and then we have the bigger triangle right here. So I think it's helpful to draw the triangles separately. So we have the little triangle that has measurements of 5 and 10, and then we have the bigger triangle that has measurements of 22 and x. So we have angle-angle similarity because we have the right angle, and then we have this angle is the same in both triangles, so it would be angle-angle similarity. And then we can solve for x. We can set up a proportion and take the 5 from the smaller triangle and put it over the corresponding side, which is x, and set that equal to, go back to the original triangle, 10 over 22. And then we simply cross multiply. So this would be 110 is equal to 10x. And if we divide by 10, we get x is equal to 11. Okay, so you should pause right now and try and do the quick check yourself. Okay, hopefully you did. We see we have this small triangle, which has measurements of 3 and 8, and then we have the bigger triangle. So I'll draw the bigger one separately. We have measurements of 6 and x. And so I can see that the 3 lines up with the 6. And so to me, this one I could use scale factor because 3 times 2 is 6. So then I know that 8 times 2 would be 16. So x is going to be 16, and the theorem is again angle-angle similarity because of the parallel sides. With the parallel sides, we would have corresponding angles here and corresponding angles here. Okay, so now we have a term called indirect measurement. And indirect measurement is a technique that uses proportions to find a measurement when direct measurement with a ruler is not possible. You can use proportions or you can use scale factor. Okay, either of those you can use whenever you have similar triangles. So if we have similar triangles, we can solve for the measurements. Okay, so a floodlight at ground level, 6 feet from a bush, 4 feet tall, cast a shadow on a building, the shadow of the bush on a building that is 24 feet from the bush. What is the height of the shadow? Sometimes you have to draw these pictures by yourself, but they kind of gave it to us. But they're saying that this bush here is 4 feet tall. So there's my little triangle. 4 and 6, and then my bigger triangle is this whole thing. And so here for this length you're going to have to add the 6 and the 24 and get 30. And then this is what we're looking for, the height of the shadow. So this is kind of a strange question because usually when we look at the shadows they're going to be on the ground, but in this one it's a little different because they're shining the light. So the x corresponds with the 4, and we set that equal to the length in the big triangle is 30 over the small triangle, which is 6. And then we get 120 is equal to 6x. If we divide by 6, 120 divided by 6 is, I'm going to use my calculator. Oh, it should be, sorry, 120 divided by 6 is 20. Thought so, but I thought I'll double check. Okay. So now, look at the next example. See if you can, again, I would pause and try and set this one up myself. You see here we have a little triangle. Right here. And the measurements are 21 and 24. And then the bigger triangle is this, and we're looking for the height of that building, and this is x, and here they show that the 56 is the entire length. So we're going to set up our proportion. X corresponds with 21, so x over 21 is equal to 56 over 24. So here I'm going to multiply 56 times 21, and I get 1176 is equal to 24x, and so then just divide both sides by 24, and x is equal to 49 meters. Okay. Now example 3. Mark lies on the ground 45 feet from his tent. Both the top of his tent and the top of a tall cliff are in his line of sight. His tent is 10 feet tall, and the tall cliff is 400 feet from his tent. How tall is the cliff? So they give us the picture. We have this little triangle here with measurements of 10 feet and 45 feet. And then we have the big triangle. And here, just look at your picture and hopefully you see that we're looking for this height, but here the triangle includes both the 400 and the 45. So we need to add those together. And then we're just going to set up our proportion. X over 10 equals 445 over 45. And if we cross multiply and divide here, we get 4450 divided by, we get 98.9 feet. Okay, so it's almost 100 feet. On the quick check, this one's a little, I'm not the best drawer for something like this, but it says the water in a lake is 5 meters deep, 3 meters from the shore. What is the depth of the water? 62 meters from the shore. So we just need two similar triangles set up, but I'm going to call this the lake, and I'm going to say right here, this is 5 feet deep, and this is 3 feet from the shore. Obviously my picture doesn't match very well. And then here, this is 62. Oh no, we're looking for the depth of the water. So this is X, 62 meters from the shore. So the 3 lines up with the 62 and the 5 with the X. So now we're going to cross multiply, and 62 times 5 is 310 is equal to 3x. Divide by 3 and you get 103.3 meters. So that would be how deep the water is. All right. Next, a person 5 feet 3 inches tall cast a 6-foot shadow. At the same time of day, a lamppost cast an 18-foot shadow. What is the height of the lamppost? Okay, so Now you see we have the two similar triangles, but 5 feet 3 inches. So that's usually the tricky part here, is we have 3 inches out of a total of 12. So that's going to be 5.25 feet. And now we just set up our proportions. I can put x over 5.25 and set it equal to 18 over 6. Cross multiply. 18 times 5.25 is 94.5 is equal to 6x. And divide by 6 and you get 15.75 feet. So that is the height of the lamppost. Quick check. Each time Old Faithful and Yellowstone National Park erupts, rangers can estimate the height of the geyser by comparing it to the height of a tree. First, the rangers locate a tree of the same height. The shadow of the tree is 93 feet at the same time that the shadow of a 6-foot ranger is 4 feet. Find the height of the tree to the nearest foot, which would be the height that the geyser rose. So again, I would try and pause and do this myself. Okay, so my geyser, so I know what a geyser is, but here's the geyser that's shooting water out of the ground, and they want to know how tall that is, so they look over here and find a tree that's the same height. And then they're going to look at the shadow of the tree, which is 93 feet, at the same time that the height of there's the ranger, he's 6 feet tall, is 4 feet. And we're looking for the height of the tree, which is going to match the height of the geyser. So we're going to put x over 6 equals 93 over 4. And we're going to cross multiply. 93 times 6 is 558. Is equal to 4 times x, and then divide by 4, 139.5 feet. The last couple examples are a very similar type problem that you'll see. It says Marie stands 8 feet from a mirror on the ground. She can see the top of a 100-foot radio tower in the center of the mirror. Her eyes are 5 feet from the ground. How far is the mirror from the base of the tower? Whenever you have problems like this, you're going to put your mirror here in the middle, okay, and then go off into 2 different directions. So here, we want to know how far the mirror is from the tower. So there's our x when the tower is 100 feet. And then here they give us that this person is 5 feet tall, and they're 8 feet from the mirror. So 5 is going to line up with 100, and then 8 with x. So I get 800 is equal to 5x when I cross multiply, and 800 divided by 5 is 160 feet. Now the quick check is the last problem, so please try and pause. I'm about to run out of time, so I'm going to pause and then put the answer up. Okay, a mirror is on the ground 8 feet from Ricky and 19 feet from a flagpole. So here's the mirror, and it's 19 feet this way and 8 feet this way. And then we want to know how tall is the flagpole, and we look at this person is 6 feet tall. So I've set up my proportions. 6 over x equals 8 over 19, and when I cross multiply and divide, I get x is 14.25 feet. It's the last example. Thank you.